Okay, so again, on our example 8, cut me off a little bit on the second part of this. So we need to find the angle that she needs to go to return home. So it says, in what direction must she walk to head directly home? So what that's asking, and then see here on the answer blank, it says how many degrees north of east. So what that is implying, she's right here. There we go. So we're saying how, let's say this is an east-west line. We want to know how far north of east. So it's asking for this angle right here, which this line is parallel to this line. So what it's really asking is how many degrees is this? Okay, so that has to do with this vector that we just found. That's this vector up here. We found the component form of that vector. So what I want to know is what the theta is. Now when I look for the theta of this vector, it's going to give me this whole distance right here. Okay, I only want this part, so once I find theta, I'm going to subtract 180 degrees from it. So I am going to go ahead and get started here. So we're going to have x, which is, we found in the last part, to be negative 7.2426. So x is equal, or we've done this enough, I think you'll understand this. So x over r, so 8.3938 is equal to cosine theta. Okay, if we use our cosine, that's going to be a second solution that we're going to need to find. We would have to use second solution on sine as well. So I'll go ahead and use cosine. And then for sine, we have y, which is negative 4.2426 over 8.3938 equals the sine of theta. Okay, so I'm going to go with cosine, and then I'm going to just check with my sine value. So go through, find the arc cosine of that value, and I'm going to pause just to make sure all my values are right. Okay, so I've got all of the numbers I need now. So when I first do this, the very first solution that I get is 149.638 degrees. Well, that would be here in quadrant 2. So I need the second solution. So normally what we've done up to this point, we would do 2 pi minus with cosine. But remember, we're working with degrees now. So we're going to do 360, which is equivalent to 2 pi. So do 360 minus that number. So 360 minus 149.638. Okay, and then that's going to give you 210.3618. And then that value is this full rotation here all the way around. Okay, we don't want that whole rotation. We only want from the x-axis down. So we're going to take and subtract 180 from that answer, and then we're going to end up with 30.36 degrees, and then that's your final answer. So a lot of steps getting to that, but as long as you understand everything that you're getting when you're getting your cosine answers, quadrant 2, you have to find that second solution. Now we're in quadrant 3, but it gives us the full angle, so we have to subtract 180 so that we have just this section right here. Then that angle, because of alternate interior angles, this angle here is going to be the same as this angle here. So this angle down here we now know is going to be 30.36 degrees. So she must head 30.36 degrees north of east to head directly home. And she is, like we said before in our last part, she's 8.3938 miles from home. Okay, one more example, and I'll probably take us the rest of the time. All right, example 9 is our last example for this assignment, but it is kind of a doozy. All right, we have a person starts walking from home and walks, and I'm going to diagram this all out the best that I can. Okay. And everything is in quadrant 4, it looks like. Alright, so she starts walking from home. Again, we put home right here at the origin. So she's got 5 miles headed east. Okay. I'm going to use a different color on that. So she's going to head out 5 miles directly east. Now, I am going to keep track of the component form of each one of the endpoints of these vectors. So what that means is that my endpoints are going to become the vector component of a vector that would start at home and go to that point. So we're good for this one. It's the vector of this exact, or the component form of this exact vector. That's going to be the 0.5, 0. Okay. Then the next one I'm going to do, the component form that we put out here is the point that it ends at, and is also equivalent to the vector that would start at home and end up at that point. So after she goes 5 miles east, then she heads 2 miles southeast. So going southeast, that's going to be a 45-degree drop from due east. So 45 degrees. And she's going to walk 2 miles. Ooh, I should have made that a lot shorter. I shouldn't worry so much about that, but we'll shorten that up a bit. Okay, so a 45-degree turn, and then this vector has a magnitude of 2 miles. Okay, so I want to find what the component form of a vector that would come directly from home to that point. Okay, so I want to know what that would be. So what would the component form be for that vector? So I'm going to go over here and do all of my work. So the angle that we would have, again, we're going to imagine that we have the origin here, and we have gone down 45 degrees. So the end of just this vector, so we're looking at just this vector right now, and it has gone down 45 degrees. So it's going to be a negative 45 degrees, and it has a magnitude of 2. So the x value, I'm going to put all my scratch work over here. I'm going to go through a lot of scratch work for this problem. So we've got a magnitude of 2, and then cosine of 45 degrees. Okay, and then for my y value, we've got a magnitude of 2, and then sine, negative 45. Negative 45 degrees on both of those. Okay, so that's going to be the component form for just this vector right here, as if this was the origin. So let's go ahead and figure out what those points are. I don't know if I have all of those on there. Just a second, I'll pause and figure that one out. Okay, so the component form of just that one vector is going to be negative, positive for the x, 1.414, and then negative 1.414. So that means that if it started right here at 0, 0, and went this direction, it would go 1.414 units to the right, and then it would drop negative 1.414 units. So now what we're going to do is we need to add that to our first vector to slide it down to the end of that 5, 0. So we need to add 5 to the x value. So now that gives me my component form of the vector where it actually is at, and also gives me the component form as if we started at home. So that value is going to be 6.414 and negative 1.414. This is also the exact location of this point. So if I was going to graph that point on a Cartesian coordinate, which is really what we're at, where we're at, this would be at the point 6.414, negative 1.414. Okay? All right, next. She is going to go 5 miles south. So 5 miles south is going to be straight down. All right, so 5 miles south. So this has a magnitude of 5. It's also the direction is going straight down. So we're going to be able to, we don't even really have to figure out, we can figure out this point easy enough, right? We know that the x value stayed the same because we didn't go left or right any. So our component value for where this vector is also would be the component value of a vector coming from home and ending here. That component value here would be 6.414. And then we've gone down 5 more. So now we're at negative 6.414. Okay? Now, we are going to go to our next one. So now we have 7 miles southwest. So southwest is going to be, let's again just kind of think of an origin here. So we're going to go 45 degrees here. Just a second, Oakley. And then we're going to go 7 miles this direction. So this has a magnitude of 7. And we'll figure out what the direction is for that one as well. And let me pause. I'll calculate the side work over here real quick. Well, let's go ahead and write it out first. So if this was the origin over here, then this vector would be 7 cosine of, what would that whole value be? 225, right? Yeah. So that whole angle is going to be 225 degrees all the way around there. So 7 cosine of 225 and 7 sine of 225. Okay, I'm going to pause because I'm afraid I'm going to run out of time on this video again. Okay, so I went ahead and calculated that. So the endpoint for this, as if this was the origin, would be negative 4.9497. That's how far to the left it's going. So we're gonna going back to the left, and then down 4.947. So we're going to add both of those values to the point where we were already at, and we're going to have a little less than negative 2, or positive 2 there, and then negative 11 something. So I'm going to pause, add those together again so I don't lose all my time. So I'm just adding these values from this vector to these values to this vector so I can figure out exactly what point we're at right now. Alright, so I added these values, which is the vector numbers for this vector here. So I added it on to the end of the values that we already had, and this gives us our exact location of the endpoint of this vector here. It would also give us the component form of a vector starting at home and going out in this direction. Alright, so it's positive 1.464 and negative 11.3637. So our last location is going to go 2 miles to the east. So we're going to go 2 miles east. And so when we go 2 miles back to the east, that's going to add 2 just to the x values. We're not going to add any to the y's at all. So I'm going to pause and figure that out. Okay, so I got my last displacement vector here figured out. I just took the one that I had from this point, added 2 to the x value. So that's my last value. So for the solutions, this person has walked a total of, well, add up all of those points, right, all of the miles, and you should get 21 miles. and then find the total displacement vector. That's the last one we ended up with right here. And if this person walked straight home, they'd have to walk how many miles? I'm going to pause and find the magnitude for that last vector, and that will be the end. Okay, so I just found the magnitude of this vector, squared them, added, take the square root, and